They say university makes students. Here, students make university. So with the slogan of Think Big, I, Himanshi Kaushik, your host of the day, would want to welcome you all in today's webinar on role of PLC in Industry 4.0. And before we move on, I hope that you all are doing fine, safe, sound, and healthy at wherever you're taking this session from. I know you're as intrigued as I am to know this new inventive session, as in what can be the role of PLC in the new industry that we're going to have in maybe the coming future, that's 4.0 or 5.0. And for this discussion, for this session, we are joined by our expert here. So I shall introduce you to our expert. Please welcome Dr. Manoj Singh Adhikari. He is a BTech in Electronics and Communication Engineering from Dev Bhumi Institute of Technology, Dehradun, India. And after that, he has done his MTech degree in Digital Signal Processing from GB Pant Institute of Engineering and Technology. Formerly, it was known as GB Pant Engineering College from Pauri Garhwal. And after that, he also has received his PhD degree in ECE from GB Pant Institute of Engineering and Technology. And after that, he started working as an assistant professor in Lovely Professional University, and presently is working as an assistant professor. And his research interests are simulations and modeling of semiconductor devices. And he has published more than 25 research papers in reputed journals and conferences like IET, IEEE, Elsewhere, Springer, etc. And not only this, he's serving as a reviewer for IEEE transactions on electron devices, AEU, that is International Journal of Electronics and Communications, Microelectronic Journal, and Springer. So it is a pleasure, sir, to be able to listen you in the session, to attend you, and to learn a lot, about the topic, about the PLCs that we will be having in the future. And with this, sir, I welcome you in the session here. And I just request you to please take over the session now. Over to you, sir.
Okay, thank you, ma'am, for giving me this opportunity, Himanshi, ma'am, and thank you a lot. And today's this is a session about the role of PLCs in the modern industry, nothing but in industry 4.0. So what is the PLC and what is industry 4.0 and what is the role? I'll tell you in the coming slides about the informations. And now I can increase slides. Okay, further. Okay, yes. So first thing is, okay, so slide, you can move further. First, I'll tell you about the PLCs. Okay, PLC is nothing but, programmable logic controllers, and PLC is one kind of the special purpose industrial microcontroller based real-time computing system. And it is one of the modern, today's controller devices used extensively for the sequential control today in transfer lines, robotics, in progress control, and many other automated systems. This is nothing but, this is the basically PLC, programmable logic controllers, and which performs the various functions, many operations in the various industries, in the modern industries, performing the various tasks. The tasks such as maybe monitor the inputs, monitor the sensors, and we are gathering the information data with the help of the input devices, nothing but we are basically using the sensors. And further we can use here the operations part, execute the logics. In this is basically a PLC, it is a programmable based device, programmable based controller. So we can make the program according our desired applications, and let us further sequencing, timing, counting functions we can introduce in that particular programming. For these are things helpful for the controlling and diagnostic purpose. And here we can also apply the other kind of the elements, that is actuators, indicators. These are the basically the output devices we can attach with that controller, nothing but PLC. And we can communicate with other systems, with other computers, with help of this controllers, nothing but a programmable logic controller. And now the evaluations of the PLCs. Basically, it's the development of the PLCs retained the basically the concept behind that is ladder logic programmings, and it evolved out of relay control panels. Earlier, we are using the relay system that is very bulky, very complex, and having the maintenance issue in the relay control systems. So we can overcome that drawback with the help of the PLCs. So PLCs adopted the legacy concepts and which were applicable to such kind of the panels, okay, forms it is available. And main thing is maintenance is very easy, and earlier is in relays having the so many wires jumbled together, very difficulty for understanding what is the right connections and where is the fault. So in that PLC system, this is programmable, so we can easily track where is the fault and how we can overcome that particular fault, how we can rectify that fault, and how we can correct that fault. Easily we can do that things with the help of the control panels, because control panels is systematically organized, and that each control here formed a rung that much like as a rung on a ladder. So this is basically the concept behind that. This is PLC based upon the ladder logic programming, where the control circuits are defined like rungs on that ladder, and each rung begins with one or more inputs, and each rungs usually ends with only one output, which is your desired outputs we can obtain with the help of that PLCs. Further, I am telling to you the informations regarding the leading brands of PLCs. What are the major brands, major companies which are manufacturing the PLCs? The most popular brand is that Allen Bradley, and the manufacturer is nothing but a American brand. This is, and Allen Bradley is the most popular. And here in our lovely professional university, in our lab, this Allen Bradley PLC is also available. Another is Gold Modicon, Texas Instrument, General Electric, Washington House, Cutter Hammer, and Squardy is another the popular leading brands in the terms of the PLCs. And I think you have heard the word of Siemens. That is another popular brand. That is the country of European countries manufacturer, the Siemens PLCs. And another Japanese countries manufacture the Toshiba. Omron is the most popular leading brand in the terms of the programmable logic controller. So these are the very leading brands of the PLCs. I can show to you the Allen Bradley's PLCs classifications. You can see first pictures is nothing but Allen Bradley PLC 5, and second is classification Allen Bradley SLC 500 series, and another is third one is Allen Bradley Micrologics, and fourth one pick you can see here Allen Bradley Pico controller. So these all are the Allen Bradley's, okay, different types of the classifications. And now I can tell you about the major components of the common or a normal PLCs. You can see here, first thing is that main important part is here processor, and input side we need to give the inputs with the help of the sensors, and output sides we are connected the output modules. Maybe the outputs is solenoid, maybe output is the contactor, maybe the alarm, maybe the motors is as a form of the outputs. And inputs from the sensor we are getting, or maybe at input side we are connecting push buttons, maybe limit switch, So with the help of these, we are giving the inputs, and with the help of the processor, we can process the input data, and we are getting the outputs according that. And main thing is that in the processor is, you can see bidirectionally is connected the nothing programming devices. So as we have done, we are creating the programs. So the things is understanding by our processor, and processor executes that command and then perform the actions. And main important part is also we have need the power supply, okay, to turns on that the processors, okay. And the entire that process is nothing but a basically inputs, outputs, processors, supply, and our interface for which is available for the programming. So these are the important parts in a or important components of a common PLCs. Now this is one of the common PLC which consists of, you can see, inputs and outputs. L1 is the left power rail, L2 is the right hand side another power rail, and input side towards the, you can see L1 having the input switches is connected, and output side you can see in terms of output bulbs is connected. So which output we want to turn on and which output we do not want to turn on, it depends upon our input conditions in our program. So we are towards the automations, we are writing the program automatically, our inputs getting the signals, then according that our output will perform the actions. And earlier I have talked to about the relay. This is one of the pics of the relay panels. You can see the here the complexity of the wiring, okay, and this is the huge in size, and this is also very difficult for the maintenance. If any wire is loose, if any wire is not working, so it is very difficult to analyze. So manually we can check, then we can are getting which wire is not properly functioning. But in today's in PLCs, everything is based upon the programming. We can easily detect the fault and we can rectify it on, and this is the time saving process and easiest process. And here just I can tell you the input devices, maybe push buttons, limit switch, thumb wheel switch, level switch, and flow switch. So through any kind, depending upon the applications, what are your applications, and according that we are giving the signal according the different kind of the input devices. And input devices, apart from that, maybe the sensors. Let us here you can see first pictures about the level sensor. Okay, if you want to fill the water tank, so how you can understood up to which level water is filled in a water tank. So for that purpose, basically we are using the level sensors, and with the help of the level sensors, we are getting the accurately up to which particular level our water tank is filled. So without any kind of the losting of the waters, without any kind of wastage of water, we can say, so we can save the water. And second is temperature sensor, and if you want to measure the temperature of a particular elements, particular components, particular machines, particular any kind of environment, so we can use the different kind of sensors. Let us, I have shown to you here the figure. This is the temperature sensor 837T. It's the limit for measuring the temperatures from -50 degrees centigrade to plus 250 degrees centigrade. Having a wide range of temperature limits, we can measure up to -50 to plus 250 degrees centigrade temperature with the help of A3T temperature sensor. So these are the all the sensors easily we can connect with the help of the PLCs. And the another things, nothing but output devices. Maybe the output devices are motor, solenoid valve, LED display, heater coil, lamp. So these are all the things according to the applications we are connected. along with the PLCs, and we can then work according our applications. This is, you can see, one of the PLC based system, how we can connect inputs and how we can attach outputs from the PLCs. You can see multiple inputs which we can connect, and as well as multiple outputs we can connect in through the PLCs. And the PLC operates multiple inputs, and you can see also we can connect different kind of the outputs according our desired applications. Now next I can move into the flexibility part. Okay, so you can see what are the features of a PLC. The features of PLC is first, flexibility. Earlier 15 machines, let us, required for 15 controllers. Now it is possible we can use only one PLC to run many machines. Okay, so that is the flexibility. Earlier we are a number of machines required for the, let us, a number of controllers, but today it is possible with the help of only one PLC. We have no need a number of machines and number of controllers. So we can connect only one PLC, then we can run many machines. Second is the features of the PLCs is implementing changes and correcting the errors. In a wired relay type kind of panels, it is very difficult. But here, and earlier, and not having any program sequence, okay, kind of things, we have required time to change, to find out the errors, where is the problem. But here, no rewiring required in the PLC system, and even the programming errors can be easily corrected through the ladder programming in the PLCs, and we can change also our programming for different applications quickly according our requirement. We can change the program easily. And next features of the PLCs is large quantities of contacts. Means relays have limited number of contacts, but in our ladder diagram, 100 of contacts can be made available if sufficient computer memory required for that. Okay, so here is that the things is large number of contacts we can connect easily. And next feature is lower cost. For more number of functions, let us timer, counter, sequencer, all the things we can package together into a smaller and less expensive PLCs. Now I'll tell you about the other features of the PLCs. Speed of operations, and the speed of PLC operations is determined by the scan time, which is the matter of in millisecond it will operate. And next one is the ladder or Boolean programming methods. A PLC programmer may be expert in digital or Boolean control, and it can also perform PLC program. Those are known the Boolean functions, those are known the digital control. That kind of the expertise easily can operate the PLC program. So a PLC program can be done simply in ladder mode by any kind of the electrician or technicians. Next feature is reliability and maintainability, and it is reliable and also easy, very easy for maintenance. Next is ease or change in programming. PLCs can be reprogrammed quickly. If you are writing the program, it will save in our memory. It is that us wasting our memory. But we need to change our program. So easily we can quickly remove that early program and we can rewrite new program. It will also save our memory, program's memory. So mixed production processing can also be accomplished here. For example, if part B comes down the assembly line, while part A is still being processed by the reprogramming in a matter of few seconds. And now I can tell you what are the advantages of PLCs. PLCs advantages, another here is, it is basically mm, solid state component. Basically it means it is highly reliability, its reliability is very high. And programmable memory means simply we can change the or modify the older earlier or older programs. And small in size, and means it will minimal space requirements is there. And it is microprocessor based. Already I had told to you earlier, PLCJ microprocessor based real time computing systems. So this is a microprocessor based, means it's having the communication capability, higher level of performance, higher quality products, and multifunctional capabilities. And it is a basically software based, and we can introduce timers, counters also, including softwares. So basically it eliminates the hardware parts, okay, and easily change the presets. And next is its advantage of features is software control relay, means it reduces the wiring cost, it reduces the hardware cost, and it reduces the space requirement. We can reuse the space, we can according our desired things, we can eliminate, we can remove previous program and new program we can rewrite. Modular architectures, its installation flexibility, our software we can easily install, reduce the hardware cost, extra, and having also expandability. This is the modular architectures. And also variety of input and output interface, remote input and output stations, eliminate means long wiring. Okay, we can connect the through the communications protocol we can use, and sending, transmitting the signals, and turns on any kind of outputs and sending the signal towards the outputs. Diagnostic indicators, reducing the troubleshooting times. Modular input output interface means easily we can maintain, and near appearances of the control panels is here, and quick input output disconnects. So here the service without the distributing the wires. Another advantage here feature system variables stored in memory data. Useful management of maintenance is required, and can be the output in report form. We are getting the output in report form here also. Okay, because our system having variables which is stored in the data memory data, so we can easily find out the output in terms of the report. And now I'll discuss some disadvantage of PLCs. PLC disadvantage is fixed program applications, means some programs are single functions applications, so it is not good to use APLs. For example, if you can switch on only one bulb, so why we are using that PLC? Okay, we can simply use one switch, but where is the multiple switch we can turn on together? There are 10 floor in a building, we can turn on all lights together, we can turn on all fans, all AC, let us, then we can connect through the PLC. But only we can turn on only one switch, only one bulb, so why we can use the PLC? This is one is the some applications that is single functions, that's why it is not good, we can use the PLC. The fixed circuit operations, if the circuit operation is never altered, then we can fix the control, is cost effective than a PLC. Okay, if we not want to change, we can fix the controller, then it is we can use that, not using the PLCs in that for fixed circuit operations. Next is environmental considerations. Certain process environments such as high heat and vibrations can cause damage the electronic devices in the PLCs. And next disadvantage is fail-safe operations, means on power interruptions, relay type panels stops the system and does not automatically restart. Okay, when we are using early relay, if the high power will come, so any power interruption is there, so system is not start automatically. But here we are already giving the program, so according that it is continuously works as we are feeding the program, as we are giving the program. So PLC may do so, however they can be programmed according that we can need to do. These are the some disadvantages. And now I can tell you the applications of PLCs. Smart traffic control signal systems, we can use PLCs in smart elevator control systems, fire detections and alarm systems, and automatic machine handling systems we can use PLCs. In automatic vehicle washer system we can use PLCs. In automated guided vehicle systems we are using the PLCs. So these are the some common applications use of the PLCs. Now I can show to you, you can see in these examples, this is nothing but a water bottle filling plants. You can see we are using, let us, I can show to you here the scenario of the 3 bottles. You can see in first part of the bottle, you can see empty water bottle is keeping with the help of one robotic arm. And after some times, our pulley is moving forward, and then bottle is reaching towards the second robotic arm. And second robotic arms, what is happening? There is water is filling up to a particular limit. There is a one limit sensor also there, and it will gives the particular amount of the liquid, and it will fills up to a particular levels. And when the timer is over, that particular amount of liquid is filled, then bottle is moved further through a pulley system, and after some particular time, then another third robotic arm pick the cap and put on the top of the bottle. So, and further another, our robotic arm, you can see pick and place for the further packaging purpose. So how the automation is happening here in a water bottle filling industry, how the water bottle is coming and filling automatically and going for the packaging purpose. So here is timer we are using here. Then we can use also counter is here for counting purpose. Timer we are keeping here, having no any kind of the mishappening. Okay, no any water bottle is further collapse. So a particular time period is we are giving when from one bottle to another bottles, and then the process continuously going on through the automations with the help of the PLCs. Now another application of PLCs I'll show to here. This is the construction industry. You can see how the raw material is as inputs is fallen down in from one end in this industry, and at output side you can see different distributor and having the different storage bins. That is, you can see 4 storage bins is here, 1, 2, 3, and 4, and mixing is automatically happens here, and the process is automatically happens here. What kind of the water we have required, what kind of the temperature we have required, what kind of the pressure is required, everything is controlled by here automatically. And everything you can see thrown of this raw material, and then it will process, and it is going to a product bin, and there is the automation is there, and after that it is further process, and it moves toward the diverter, and then further it moves towards the distributors, and there is the different levels, there are the different indications, and according that we are getting the outputs in particular which one of the bin, what is the level of the concrete, or what is the level of the our items. So everything this is controlled by the PLC. Next example or applications, you can see gas detection systems. There are hazardous area, another is the control room, another is the safe areas or atmospheric area where is the outlet is connected, and here basically inputs, solenoid valve is connected, and after that there is the filter, pump, and flow meter, and then oxygen sensor is connected. The PLC, our PLC system manages or connects the all filters, all pumps, flow meter, and oxygen sensors. So there is, you can see vacuum switch also and pressure switch also. Key pump, what kind of the pressure is required, what kind of vacuum is required. So every this kind of things is managed by the controller, nothing but that is programmable logic controller. Then goes the gas at the output side, and there is the HC sensor, H2S sensor, that is the another oxygen sensor. All these sensors are also managed by the PLCs. So this is one of the gas detection system. Any kind of, if any gas is poisonous, sometimes gas is released, so we can easily detect. We can save the thousand of lives if those are working in the industry through the this gas detection systems which are operating through the PLCs. You can see here different elements, how we are doing the communication of different components, different interfaces through communication protocols. You can see PLC is connected with the sensors, and further it is connected with motor control, HMI, human machine interface. Everything surrounded with the PLCs. The PLC is easily interface with the sensors, motor control, as well as HMI. HMI stands for human machine interface, means how easily humans can interact with the machine. We are giving one kind of the touch panels and everything in that touch panels, and we can easily give the command with the help of the touch panels, and then we can observe the outputs, we can operate the outputs, or we can see the applications. And this is one of the scanning of ladder programming. You can see left power rail and another right hand side having the right power rail, and in between left power rail and right power rail is the power flow, okay, from one end towards another end, then further diagonally comes second end and towards the first end. So this is one of the scanning, okay. This is the one of the ladder logic, ladder programming. So vertical lines is rail, power rail, left power rail, and right power rail, and in between the rail, that is known as rung number 1, 2, 3, 4. Okay, so this is one of the ladder logic. Now I can tell you the some operations, that is how we can perform the operation through the ladder logic programming. One is AND logic. You can see in AND logic, normally what is happening, if input A and B, if I'm taking two input case, if input A is 0, B 0, what we are getting output? F equal to A into B. So 0 into 0, 0. And similarly, if input 0 and 1, so when you are multiply 0 into 1, we are getting 0. Third input case condition, 1 into 0, 0. Fourth input condition, when I'm taking 0, 1, 1, so 1 into 1, 1. So this is AND logic. So simply we can design this logic with help of ladder logic programming. So I'm considering, let us input 0, input 1, you can see, and I'm out, according that I'm getting the outputs. This is nothing but here we are connecting the normally open switch in the series. Input 0 and input 1 is a normally open switch. We are connecting to series. If I'm taking three inputs, that is input 0, input 1, and input 2. So three inputs, if I'm doing the AND operations, then we are connecting three input normally open switch in series, and according that I'm getting the outputs. So here we are not writing any kind of the text language. We are just we are taking this rung, and according that we are connecting the normally open switch and output switch. Then we are observing the our operations. We can perform the here operations. And next I can show to you all logic operations, how we can make. And through the ladder logic programming, we can take the normally open switch in the parallel fashion, and we are connecting parallel fashion, and we are getting the outputs. This is the OR logic you can make by simply connecting the switch in the parallel fashion through the ladder logic programming. Another, if you want to make NOT logic, so you can take simply normally closed switch. You can see in the yellow colors I'm taking normally closed switch as the input side. It is mentioned also by name here, you can say reference X. This is normally closed switch, and I'm getting simply output there, nothing but not operation is simply if I'm doing 0, it treats as a 1, and if I'm giving input as a 1, so it will treat as a 0. It acts as an inverter, or you can say NOT operations. And here various gates, such as XOR gate, NAND gate, NOR gate, XNOR gate, we can perform these all the operations also with the help of the ladder logic programming. And now I'll tell you I'll tell you the software part a little bit also, how you can make the these logics. Okay, right now first, and then I'll come back here. Okay, and so you can see my screen. Okay, and here I can open this Logic Pro software, and this is one of the Logic Pro software. And here first we can see here, this is the simulation option. You can click on simulation, and when I'm clicking input oblique output simulator, this is my input switch is here. It is the display. This is the one of the input oblique input switch display button here, and corresponding output is connected also. Here is a ladder logic programming. You can see the already here one line, and here let's say I'm making AND logic. So what can I do? Here is the switch. You can see normally open switch. Here's the switch above here, and when you can put the cursor, it is coming examine if closed. So normally open switch I can select, drop and drag. Where is the this cross button? You can here you can left that button. Similarly, I'm picking normally open switch, and I can left in right hand side of the cross, then another switch will come. And this is the two input switch I'm taking. Now I'm taking one output switch. So here is this is the output energized switch. I'm picking and dragging and putting here at the cross in the right hand side. Then you can say simply here output switch will reflecting. How we can give the inputs come a switch? This is the input switch one. So I can simply drop and drag here. Where is the question mark? You can see here the input signal I'm giving I:1/0. And if I'm giving second input switch, so I can pick and place. I can give here I:1/1. This is the first switch. I'm taking two row. First switch is /0, second row /1. You can see 0001. I'm taking here first two switch. I'm connecting series. Now in the output side, you can see still the question mark. So it means I need to give the name. I give the switch. You can say simply which output will glown, which output will be functioning. So simply if I'm giving the output first, you can see I can click here output O:2 is mentioned here. I'm writing here in O:2/0 means first row, okay, and first output second it will I'm taking into output side. So when I'm giving the input signal, according that it will perform the action. You can see an AND logic. Now I'm connecting simply two input switch in series and one output. Now when I'm connecting here, still this software in offline. First you can connect here. You can see go online. When you are going online, after that second option is here download to PLC. This program we need to build we can keep inside the software in PLC. So download to PLC option you can click. Then now this program inside the PLC. Here is the one run button. You can click on run button, and after that run button you can see this is the two switch. I'm connecting one switch, you can see, and second switch is still on. You can see. So 1/0 means 0. If I'm closing, let us both switch. You can see both switches close. You can see yellow color close, close. So output side you can see also yellow color. It means my output side button is turns on. This is AND logic, means both switches close. So my output bulb is glown. If I'm opening any single switch, so my bulb will be not glown. My bulb will be not turns on. You can see I'm opening any one switch, so it is not one turns on. Means now logic is 1/0 means 0. If I'm giving 0/0, both switches open, you can say 0/0, output is 0. And third operation is here 1/0. So this is bulb is not glown. Another is 0/1. So also bulb is not glown. When both switches are closed, 1/1, you can see bulb is glown. And here at the O:2, you can see this bulb is also glown. This is the operations of AND logic. Similarly, you can do the OR logic when you are connecting the parallel. So I'm going offline, I'm connecting parallel. You can see the operations. I'm deleting this. For parallel operations, you can connect this switch first here. Okay, and you can take normal open switch and then another normal open switch, connect in parallel fashion, and giving the input command from here. I'm giving the input signal here. Now this is I'm creating the logic, and now I'm doing the same thing online. First you can select, then you can go download to PLC, then you can click in run button. Now you can see I'm switch number 1, I'm pressing close, so my output bulb is also glown. This is 1 plus 0, 1. And if I'm doing 0 and plus 1, 1. You can see any switch will be closed, so output will be glown. If both switch will open, you can see, then output bulb is not glown. When both switch will be closed, then also bulb will be on. 1 plus 1 means 1. Bulb will be glown. This is the simple logic here, series and parallel combinations. You can make a number of programs with the help of that. Okay, so this is the simply the logics behind that. Okay. So now according that you can make AND logic, XOR logic. Okay, yes, this is the little bit programming part here.
Thank you, sir. So are we done here with the presentation and the topic discussion here?
Yes, I have completed, ma'am. Yes, the part of this. Yes.
Thank you so much, sir. Thank you so much for this insightful presentation, for actually coming here, joining us here and giving this. So during the session, I was having certain questions, and with me, there were questions from registrants also. So I'll
Okay.
just take two of them.
Yes,
Just give
ma'am.
me a moment here.
Okay.
Yeah, okay. So first thing, the question was from Ahan Sharma, and it says, sir, in which industry would be PLC useful, and in which all industry we can use this PLC specifically?
PLCs, I have already talked, many industries already working. You can see in the water bottle filling plants. I have shown to you also the one of the scenario, okay, how automatically the robotic arm picking the empty bottles, how the bottle is filling particular water levels, and after one particular time delay, the bottle is moving forward directions, and then another robotic arm, putting the cap, and another fourth robotic arm picking that filled water bottle along with the cap, and then went towards the further packaging purpose. So in the automation industry, water packaging industry, perfectly it's used. In robotic industry it's used. And I have shown another industry, construction industry. So in construction industry, how the raw material is coming and how everything is managed by the PLCs, and then further process. Third thing is gas, leakage kind of industry, where is the gas is manufacturing, and if any kind of leakage will be there, so maybe people's having the harmfulness of that situations. So to avoid that situation, we can ultimately having the alarming systems, sensor system, we can predict early basis with the help of the PLC. We can manage, we can see, we can check immediately which particular room, which particular block happens this kind of leakage. We can easily, we can provide the treatment in there. We can easily send to our team. We can check, monitor easily. Otherwise in previously manual things, we can't predict in which place, which room, which block, in industry, which place, because industry is very vast. Okay, till it will take so much time to went there. So if we can easily predict which place having the that situation, then we can control that situation easily.
Definitely, sir. And I think this one question again came in my mind when you were telling about how PLC can actually help us and grow as an industry. So there can be multiple times when these are all computer things, right? Computer generated things and all the technical things. So let's say if there's any problem in case of like some like PLC is not actually clicking the right thing. For example, there is a gas in a room and alarm is not being switched on. Why? Because there was some technical issue that happened in the machine. Of course it's a machine, so it needs to be regularly checked. So how we can actually overcome all of these things to maintain a sanity in terms of PLC being used in industry?
Yes. So basically, we can continuously, having the monitoring of the things. Means maybe one of the operator already have tell you the things. Those are the maybe some technician. Those are getting the information, knowledge about some Boolean functions, digital functions. These are the very basics today's scenario. So they can easily operate this PLC kind of systems. There one of the monitor will be there. So one of the operator, let us, you can operate entire building. If let us in one floor having 10 buildings, in each floor having the 100 number of rooms, let us in a industry, in a company. So we can that operator, one single operator can visualize by sitting in one system every room's particular things on a real time. So they can easily look out which particular sensor, let us suppose, is not working. So they can easily get the information, and they can getting the time to rectify that error in quickly. Yes, definitely the sensor machine will be there, so definitely having sometimes issue there, but the information we can get early, we can get the time to maintain that is very important.
And I think, yes, sir. And I think this would also give a lot of, let's say, employment to the people who have mastered into this field, right, sir? And our students also from LPU have been, achieving great heights after being mastered in the particular domain. So what do you want to say on that, sir?
Yes, definitely. Today's scenario, today's is the everything is based upon the automation.
Right.
So that's why already I discussed early system is relay. That is a manual based system. But today is that thing is converted into PLC. Means programming part is there, and that programming is also connected with automations. So definitely having a huge scope in that field. Ki every you can say top leading brands companies also manufacturing the PLCs.
Right.
Toshiba, Omron, Allen Bradley, these are manufacturing the PLCs because their things is automations. Industry wants a revolution in terms of saving the time and wants more benefit in terms of productions and saving the time. So that is a good time in terms of the researcher, in terms of the higher education, student those one wants to do the engineering in masters, bachelor degree, master degree, or in it's and also doctorate degree. So
Right.
it has huge lot of scope.
Definitely, sir. And I think, sir, we're done with the queries here. And with this, I just want to urge everyone, if you're listening here or maybe in the YouTube or anywhere else, because this will be available on our site as well. What you can do is you can just try to, let's say, visit our campus, visit our department here, and you can see how furnished labs we have and how much quality education do we provide. So with this, sir, I just want to say thank you so much for
Thank
coming
you.
here and the way you have presented and giving explanation of all the questions that we've been asking you. Thank you so much, sir, for this.
Thank you, ma'am, for giving valuable this time and opportunities. Thank you once again, ma'am.
The pleasure is all ours. And at last, I also want to say thank you to all the attendees. Now, sir, I just want to take your permission to wrap this session up. Shall I?
Yes, sir. Yes, ma'am. Yes, ma'am.
Thank you so
Thank
much, attendees,
thank you.
for joining in. Thanks, sir, for coming in here,
Welcome.
crediting your time. And maybe we meet soon in university physically. But if not, then for sure, we're going to meet in the next webinar. All the webinars are lined up on our site. So until then, stay safe, stay healthy. And thank you so much for joining in again.